Okay, jump cut to this example that you do not have in your packet. I just wanted to talk about like, what does this actually mean? Like, what is an average value? Okay, so f of x is going to be this line in this first problem, and f of x is going to be the curve in the second problem. And I've already drawn out like a and b on both of these and then done the little area business. So this is what you would do like your Riemann sums for, or if you wanted to find an area of that, you would like take your integral, right? Okay, so this guy's a rectangle. We know how to find areas of rectangles. Area is base times height. The height of this rectangle is f of x. It's the y value. It's consistent the whole way across, so we know that that is always f of x. In this case, it looks like 3, right? The base is the difference between b and a. You just subtract the two. The area is the integral from a to b of f of x dx. Okay, we've done that integral before. So if we want to find the height, let's say we just didn't know that it was 3, but we could figure out the area because we know a function, and we can subtract b and a. We know how to subtract. We can really just divide both sides by b minus a and put 1 over b minus a here. And now we have found the height of our rectangle. You're like, okay, but that's a rectangle. This guy's a crazy looking shape. So how do we find the height if it's not actually just straight across? Well, let's set up the same kind of deal. The area is going to be the integral from a to b of f of x dx. And that's going to equal the base, which is b minus a, times the average height. Okay, because this is still not a rectangle, but we could kind of pretend it's a rectangle. What if we just draw like across here? Then like this area, I didn't draw it very symmetrically, but like this area and this area would kind of like fill in. So like get rid of this and put it here. And we can kind of like force a rectangle. This height right here is the average value of f of x. Okay, so the average height or average value of a function is the height that would turn your shape into a rectangle and still have the same area. Cut that out. Average f of x, average value. Cool, so it's like the average y value. Average f of x. Cool, so that's what we're looking for. It just so happens to be a rectangle on this first guy. Cool. Let's go over here. Back to our actual notes. Find the average value of the function of f of x equals blah, blah, blah. Okay, so we're trying to make this into a rectangle with a certain height. So what is the height that would make it a rectangle that has the same area as the curve has? Okay. We know that we need the 1 over b minus a. We need the integral from a to b of whatever this function is, because this is the function that we draw. So that's the function we need the area for. Oh, in this case, we have 1 and 3. So I'm going to erase a and b and put 1 and 3. This is 3 and 1, 1 and 3. Oop, 3, there we go. Okay, it's always b minus a, top minus bottom, every single time. Okay, we are told to use a calculator on this one, and that's because we do not know how to take an integral of this by hand. So I've already plugged that into y1 just to save us some time. However, we should talk about why we're plugging certain things into certain places. Okay, so I've got my x cubed first times the square root. Okay, now this is sine of x squared. Now you might be thinking, don't square roots and squareds cancel each other out? The answer on this one is no. Because notice that sometimes sine is negative. So by squaring sine, you make every value positive, which means you can take a square root of every single x value, whatever that you plug in. This is defined everywhere. just sine of x would be negative in some places. So this is gonna actually turn everything positive. So that's a little bit weird, but that's what's going on. Okay, the other thing to notice is that I put the squared after the sine, not in with the x. So I did an extra set of parentheses, so it's sine of x in parentheses with an extra set of parentheses and then squared. Okay, there's no way to put the little squared in between the sine and the x on these calculators, unless there's some function that I have not found in the last 15 years. So if you find it, let me know. Notice that my calculator is in radians. If yours does not say radians, make sure that you go into mode and get that fixed. Calculus is always going to be radians. All right, I'm going to quit out of this, and on my home screen, I hit Math 9. We're going from 1 to 3. We need y1. I'm going to hit second and then trace to get to this. Not second, Mrs. Campbell. Get back to there. Alpha, trace. There we go. Y1 is what we're looking for. You could have gotten there using vars as well, right? Vars, right over to y vars, and then hit enter twice. Okay, and then over here, we got to do our dx. Hit enter. This gets us just the integral portion. We have not done the 1 over 3 minus 1 bit. But isn't 1 over 3 minus 1 just 1 over 2? So we can take our answer for this and just divide it by 2. Okay, so you can divide by b minus a after you evaluate your integral. And that'll save you from doing like the fraction with 1 over 3 minus 1 times and then do your integral. You get the same thing. This just takes a little bit more effort, I think. Our answer here is 5.848 because of our 3 decimal places. 5.848. And we are not given any labels, so that is it. That's the average value of f of x. This is the height that, actually, let's graph it. Why not? It'll take a million years, that's why not. Woo! All right, here's 1 and here's 3. All of this area that's in here, if we like make a horizontal line at 5.848 between 1 and 3, that rectangle would have the same area underneath it as that whole curve between x equals 1 and x equals 3. Next one, find the average value of this function on that interval, and it's a non-calculator problem. Finding the average value of f of x, so f of x goes in here from a to b. Ooh, gotta put that dx at the end, and then put 1 over b minus a, because you have to divide the area by the width to get the average height. Width, 1 over width times area equals average height. Sweet. So this is 1 over 6 minus 2, integral 2 to 6 of f of x, that is 2 minus 4x dx. We're doing this with no calculator, so this should be an easy integral to calculate by hand. I'm going to put this 1/4, and then I'm going to put brackets for this whole thing. So it's going to be bracket minus bracket. Oh, we got to take the integral first. Okay, so 2 has an integral of 2x. Negative 4x squared has an integral of negative 2x. Oh, I said squared because I knew it was going to happen. Okay, so this is 2 times something minus 2 something squared. 2 something minus 2 something squared. Top one first, 6, 6. 2 on the bottom, 2, 2. 1/4 times, 12 minus 36 times 2, 72. So 72 minus 12 would be 60. Negative 60. Woo! You can absolutely do this off to the side so you don't have to show all of that work or do it in your head. We're just kind of trusting me that I know the right answer to that, I guess. All right. Also, it's that way on the answer key. Minus 4 minus, that's going to be an 8. 4 minus 8 is negative 4. I'm putting the extra brackets because this 1/4 is multiplied times the whole thing, that whole answer, not just times the first brackets. Hopefully that's obvious. So it says 1/4 times negative 60 plus 4. So 1/4 times negative 56. 56 is 8 times 7, which would be 4 times 14, so negative 14. Yay! So our average height is negative 14. Okay. If this were me doing this problem, I hated that I had to write those brackets over and over. So what I would do if I was calculating this, I would set it up, and then off to the side, I would calculate this integral. Like I would do all of this work off to the side and then plug in the answer of negative 56 right over here next to that 1/4. So I don't have to write the 1/4 a bajillion times.